Alright guys, so welcome back to series 4. We're going to do lesson 1, quadratic regression. This unit is about the applications of quadratic equations. So the first thing we're going to do is to reset our graphing calculator. So that would be us pressing second plus 7 on 0. Okay? So at the end of that process, you will see that it says all the stored, or the memory that's able to be moved is removed, actually. And so we're going to go on here, and there's 3 lessons in this unit. We do have the one major quiz coming up, and it's on the 15th of November, and it's on factoring, so we'll be reviewing the factoring in each class. And then you have 3 assignments on math space. It's up to you to complete those tasks and to stay up to speed for that. So moving on, we're just going to jump right in. And a couple of things worth looking at is the quadratic equation, except at this point they're going to give us points, and those points could fall on the curve, or they could not be on the curve, like so. So what a quadratic regression does is that a quadratic regression is the process of finding the equation of a parabola that best fits a set of data. So when we're given a set of points, we'll plot the points, and it could look like this first picture, or it could look like this curve where all the points fall on the curve. This is a line of best fit here. Or it could look like this, where it's just very random and correlation is very off. So what we'll be doing is crafting models, basically, or actually we'll be discovering quadratic regression equation. And you need a set of points in order to do this, in order to craft a model with the graphing calculator. So we're going to model the data by graphing it with the graphing calculator. So the first thing we're going to do, I'm not going to go through this yet. What I want you to do is, in the margin of your paper, of your notes packets, you're going to write a couple of things, recall a couple of things. So the first question is going to ask you to find the equation. Okay? Find the equation. And the way you do that, you press stats. You go, actually, erase that. The first thing we're going to do is to turn on stat diagnostics. Turn on stat diagnostics. Stat diagnostics. And how do you do that? Well, one, you press mode, then you go down to stat diagnostics, and you want to enter on, okay? The second thing we're going to do is to find an equation. Actually, take that back. We're going to enter the data. Or the points. And for this, you go to stats and edit, and your list should be clear. So if you're resetting every time and you're turning stat diagnostics on, you're perfect and good to go. Now, third thing we're going to do is to find the vertex. Find the vertex. Okay? So we'll press zoom. We're going to press zoom, and then 0 for zoom fit. Okay? And that should enable us to go to our graphing calculator and see this equation on our graphing calculator. The fourth thing, well, that's find the vertex. So after that, you're going to go to press second trace, and you're either going to hit minimum or you're going to hit maximum. Make sure you're writing this down. Very, very important that you write this down. Okay? Next thing we would do for this one, for this type of problem, is we're finding y. Finding y. Okay? So all you do is substitute in x, okay, and find the solution. Substitute in what x equals. The last thing we're going to do is find x and substitute in y and use a couple things we have to do here. Put the equation in standard form. So everything's on one side. And then we're going to use the quadratic formula to solve for x. Okay? So we're just going to go back through and do these things each time. Okay? So things I want you to notice about your data. The amount of paper comes in thousands of pounds. So for 2 is actually 2,000. 4 is actually 4,000. 5 is actually 5,000. When x equals 8, it's actually 8,000 pounds. This is 9,000. This is 10,000. So keep that in mind because they go back and forth between using 2 and 2,000, for example. And then for production costs, this is actually $5,000. This is $3,500, $2,600, $2,375, $2,600, $2,975, and $3,500. Okay. So find the quadratic regression equation that models the production of the paper redundantly. So I press stat, I go to edit, put my numbers in, list 1, 0, 2, 4, 5, 8, 9, 10. Let's put that change there, 9, 10. Okay, then I right arrow over to list 2. We have 50, 35, 26, 23.75, 26, 29, 29.75, enter, 35. Okay, so this calculator is only as good as you make it. So your answers are only as good as you input the numbers in correctly. So go back and check your numbers. Then we're going to go and get the quadratic regression equation that models this data. So I press stat, right arrow over to calc, and I'm going to go down to number 5. Go down to where it's the store regular equation. You're going to store this equation into the y equals function. So press alpha trace, press enter, and enter, enter. And I get 0.75 minus 9 plus 50. So 0.75 x squared minus 9x plus 50. It wants me to find the vertex, so we're going to be using that information right there. Where it says find the vertex, the first thing you do is press zoom, go to 0 for zoom fit. And there's my equation. There's my graph. I press second calc, second calc, second calc, or second trace for the minimum. This is a minimum, and it's to the left of the minimum, and then I go to the right for the right value of the minimum. So the way you'll know that you're at the right of the minimum is you'll see that cursor going up like what looks like a cliff to the right of that minimum, where you think it's at, and I press enter, I guess, and I get 6, 23. 6, 23. So the minimum cost, looks like the best place to be would be when there's 6,000 pounds of paper and you're paying a minimum cost of $2,300. Okay, that's the best price you could have. So for the next part, it's going to ask you, find the amount of paper that should be reduced in order to minimize cost. Hint, find the minimum. Well, I know the minimum is 6, and so the minimum cost occurs when y equals 23, or it's actually the minimum cost is $2,300. Minimum cost, or the best cost. Now, for the next one, we're going to be using the black part, finding x, finding y, we substitute in for x. So we find the cost is y, of producing 12,000 pounds of paper. This is what x equals 12. So we use the equation we have. We have y equals 0.75 x squared minus 9x plus 50. And what we're going to do is we're going to substitute in the x here, in this equation here. And I have that this equals 0.75 times 12 squared minus 9 times 12 plus 50. And I'm going to put that exactly as I have it written into my calculator. So I go to second mode to go to the home screen, press 0.75 parentheses 12 close parentheses squared minus 9 times 12 plus 50. Press enter and I get 50. So at this point I'm paying $5,000. The cost equals $5,000. Now, find how much paper will result in the production of cost of $4,000. So y equals 40. We take those two zeros off. So we take our equation again. We say 40 equals 0.75 x squared minus 9x plus 50. Now, what did I say before? Finding x. Substituting in y, we did that. Put the equation in standard form. So I'm going to put 40 on both sides, or subtract 40 from both sides. I get equals 0.75 x squared. And I'm going to use the standard form of this equation to solve for x using the quadratic formula. So x equals negative b plus or minus what's inside of this radical. So I have b squared minus 4ac divided by 2 times a. This equals negative. b is negative 9, okay, plus or minus the square root of okay, so I'm just going to go back and fill this in here. So b is negative 9 squared minus 4 times 0.75 times 50, and then 2 times 0.75. So I'm going to do this part by part. I'm going to simplify part by part. And so what does that look like? What does that mean? Well, I'm going to highlight the parts that I'm simplifying. So here, inside, and at the bottom. So here, inside, and at the bottom. So I'm going to go back and fill that in here. So I have my dividing line, plus or minus, I have my radical. Okay? So, negative times negative 9 is a positive 9, and 9 squared is 81, minus 4 times 0.75 is 50. You should get 51 here, divided by 1.5. So, breaking these apart, x equals 9 plus the square root of 51 divided by 1.5, and it equals 9 minus the square root of 51 divided by 1.5. Using the graph and calculator, you have alpha y equals answer 9 plus the square root of 51.
Good morning, West Potomac. Just a reminder to advisory teachers of 10th and 12th grade students, please be sure to stop by Student Services this morning to pick up your Fairfax County survey. Thank you very much.
6 here for my first answer. And then for my second answer, minus the square root of 51, I get 1.2. 1.2 equals 1.2. Okay? So, bringing these answers back up to where they need to be. So, how much paper will result in $4,000 in production costs? Well, X could be 10,760 pounds, or 1,230 pounds. So, best scenario here is you get more bang for your buck and you're getting 10,760 pounds. Okay? Moving on to the next one, we're going to do the same thing. So the table shows the average sales price, P, of a house in Suffolk County. So we're using different variables here, but it's still the same. This is X, this is Y. The only difference is we're replacing X and Y with these other two variables. So since 1988, year 0 is 1988. So that means year 2 is 1990. This is 1992. This is 1994. And we'll want to reference this. We want to write these things down so that we're able to easily reference the year. Average sales price in thousands. So this would be 165 is 165,000. So on and so forth. So just recognize that, keep that in mind. So we're going to write this in with XY coordinates, and then we're going to write this with the PT coordinates. Because the first part says write the quadratic equation that best models this data using variables T and P. So what I'm going to do is I'm going to go and press second plus 712. This will clear out my list. I'll go back to stat, press edit, and put my numbers in. 0, 2, 4, 6, 8, 10. On the right, put my numbers in. 165, 154.5, 124.5, 115, 128, 165. Okay, now I got my numbers in the data in, so I press stat, go right over to calc, and press 5 for quadratic regression. I'm going to store this equation into y1, so I press alpha trace. Sorry, my bad. So go back over to calc, 1.25. Go down to store regular equation, press alpha so the A shows up, and press trace, enter. And now I just calculate. And my equation is 7.83, negative 13.55. Okay, so y equals 1.83 x squared negative 19.55 times x plus 170. Wrong thing. Plus 172.3. Okay. And I want to write this in terms of T and P. So I write T. Nope, I'm replacing, let's see. T is an X value, P is a Y value. So P equals 1.83 T squared minus 19.55 T plus 172.3. Final answer. That's my answer. And what year was the sale price lowest? So we're going to find the minimum. Keyword being lowest. The minimum P value, or P value, or Y value in this case. So we're going to use the graphing calculator for this process. And while I'm here, I'm just going to go ahead and go to mode and turn on stat diagnostics so I can get my correlation coefficient. There it is, and I press enter on, and I go to y equals, my equation's in there, press zoom, 0 for line of best fit. And there's my parabola, there's this curve. And I'm going to go it's a minimum, so I'll go second trace, and I go to minimum, and I press enter on the left tab, and then I go over to the right side of this minimum. Press enter again, and I'm at 5.34, 120.45. So 5.34, 120.45. So essentially, the sales price is lowest. Looks like when it's 1988 plus 5.34. That's about 1988 plus 5.34. It's the mid-year of 1993. 1993. That's what we can say. And the lowest price would be $120,400. But the year itself is 1993. What is the correlation coefficient for the data? We're just going to go back to the calculator, graphing calculator, press second mode, and go to stats, and then just go back over to quad regression. So we can calculate this R value. And my R value, R squared, is 0.86. So this data is very close to the absolute value of 1. R is very close to the absolute value of 1. So the curve demonstrates that predictions are easy to make. And just a little recap about our correlation coefficients. So if R is so my R value, my correlation coefficient, So what does this mean? Well, my R values, they range from -1 to 0 and 0 to +1. Okay? So if you look at 0.86, it's very close to +1. And this means that the curve is, I think, a really good fit for the data that's presented. That means you can make good predictions. So here, well, the closer you get to 1 and -1, the better predictions you're able to make.
Good morning again, Ms. Potomac. Just a reminder,
Now,
faculty members who have advisories with 10 and 12.
so if it's close to 0, I'm not making good predictions. I am not. These predictions are off. The data is scattered. And if you're still confused about that, I would go back to Unit 2 and check over linear regression. We covered scatter plots. But we're going to move on. So I know I have to reset my graphing calculator. All right? So while I'm doing it, I'll read through this. So, it says a study compared the speed X in miles per hour and the average fuel economy Y in miles per gallon for gas. The results are shown in the table. The first thing it asks us to do is to find the quadratic regression equation. First thing I'm doing is turning my stat diagnostics on. Pressing enter, and then I'm going to stats. Everything should be cleared out. And then I'm just going to go use my table here. Right? Let's minimize stats. Let's minimize stats. You know what? I have the notes, so I will use them. All right, so I have 15, 20, 25, 30, 35, 40, 45, 50, 50, 55, 60, 65, 70. Okay, go to list 2. I have 22.3, 25.5, 27.5, 29, 28.8, 30, 29.9, 30.2, 30, 30.4, 28.8, 27.4. This is a lot of numbers, so you probably want to make sure that you have the same amount of numbers on each side. After that, we're going to go to stats. We're going to go right over to calc and go down to 5 for quadratic regression. Then we're going to press alpha trace, enter. Oh, messed up a little bit. So go over to calc, number 5 for quadratic regression. I'm going to press alpha trace, enter. So this goes into Y1. And then I'm going to go down and calculate, and I should get my R value, which is 0.96, is very close to +1. So this is a very good curve of best fits here. And my data indicates an equation y, oh, not a, y equaling 0.008 x squared plus 0.745 actually times x plus 13.07. Okay? Now that's my equation. The next thing it asks me about is what do you predict the fuel economy at 75 miles per hour? So 75 miles per hour is an x value. So when x equals 75, what's y? Question. So we take our equation, y equals 0.008, substituting x, 75 squared plus 0.746 times 75 plus 13.07. Go to my graphing calculator, put this in exactly as it is. Sorry, that's a negative in front of that 0.008. It's incorrect there. There's a negative. So you be careful and double check your graphing calculator. Press negative 0.008 times 75 and it's squared. Make sure you close the parentheses. What I did. Parentheses. Parentheses squared plus 0.746 times 75 plus 13.47, enter. And I get 24.42. I have a fuel economy of y being 24.42. And my units are gallons. Okay? Now, it says, what is the best speed for maximum fuel economy? And we're probably going to be looking at a maximum here today. So we're going to go find that vertex. That's a key word for find the vertex. So we're going to go find a vertex, find the best speed, that's this x value. And we're also just going to find y, or the number of gallons. So, go to grab a calculator, make sure my equation's in there, and it is. And I go to second, press zoom 0 for the curve of best fit, so I can see that curve there. And then I press second, for second trace. Apologize, guys. Second trace, and I go down to maximum. This is a maximum. It says maximum fuel economy. And I hit the left of that curve, and then I move over to the right until I'm to the right of the curve. I want to be over and to the very top of this curve. So it might take me a little bit, but I'm going to do it. Let's see here. You can tell because the y values will start to decrease. And we're going to 28, 29, keeps increasing. My y values went to 30, still increasing. Looks like they're decreasing if it goes down to 29. So I'm at the other side of the maximum. And I press enter and enter again, and my maximum is 45.49, 30.44. So I have 45.49 and 30. Let's make sure that 30.44. So the answer is the best speed is 45.49 miles per hour. Okay, moving on. we are at example 4. So the table shows how wind affects a runner's performance in a 200-meter dash. Positive wind speeds would correspond to tailwinds, and negative wind speeds correspond to headwinds. Positive changes in finishing time mean worsened performance, and negative changes means improved performance. So your graphing calculator, use your graphing calculator, draw a scatter plot and quadratic parabola of best fit. What is the equation of the parabola? So here we are going to go to our graphing calculators. Resets if you would like. I'm not going to at this point. I'm going to go directly to stats and press stats. And then I'm just going to clear out my list here.
Good morning again, faculty.
Okay, I'm entering my listing. So 0, enter, 2, enter, 4, enter, 6, enter. On the other side, I have 2.28, enter, 1.42, enter, 0.67, enter, 0, enter, negative 0.57, enter, negative 1.05, enter, negative 1.42, enter. Now, for that, I'm getting the equation, so I'll go to stats, right arrow over to calc, hit number 5, quadratic regression, and I want to put this equation in Y1, so I press alpha trace, enter, 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 and I get these numbers. I get y equals 0.017 x squared plus 0.29x plus 0.33. Correlation coefficient is 0.91. So this is very close. This very closely models this data that we're given. So I'm going to write the equation first. So I go down, write the equation. I get y equals 0.0017 x plus 0.29 times x plus 0.3. Okay? Now, what would you predict the wind speed would need to be to change the finishing time by negative 1.75 seconds? So what do you predict x should be? So we're looking for x when y equals negative 1.75. So x could be between these two numbers, so about negative 5, or x could be above at 7. But let's just see what this is. So we're gonna plug this number into the equation, and we're gonna use the quadratic formula. So I'm gonna be writing very tiny, as small as possible. So I have negative 1.75 equals 0.0017 x squared plus 29x plus 0.33. Subtract, add 1.75 on both sides, and we're putting this in standard form here. And I get equals 0.0017 x squared plus 0.29x plus 2.08. Okay? Now we're going to use a quadratic formula. I'm going to use the margins of this document, and I hope that you would too, in order to get our x values. So we have negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So this is negative 0.29 plus or minus the square root of 0.29 and it's squared minus 4 times 0.0017 times 2.08. all of this divided by 2 times 0.0017. So we're going to use our graphing calculators here to calculate this information. Okay, so part of it I have to, so I get 29.29 plus or minus some number inside of the radical times divided by 0.0034. So let's get the number inside of the radical. Number inside the radical, press second mode here, and I get parentheses 0.29 close parentheses squared let's use the squared minus 4 times 0.017 times 0.33, close the brackets, and I get 0.08, and I'm going to take the square root of that, second square root of that answer, and I get 0.286. 0.286. So over here in the margins, I get, this is like, this equals, this is like 0.086 in the back. I get 29 plus, as one of my answers. Let's see what we have here. 0.286. Plus 0.286. Okay, it's first answer, comma, 29.29 minus 0.286 divided by 0.0034. And for this, we are going to use the graphing calculator to calculate these answers. So press alpha, y equals, enter. Okay, put alpha, y equals, enter. I get 0.29 plus 0.286 divided by 0.0034. Enter, and there's my first answer. That's a big number. And my second answer, that's a big number. My second answer, alright, I'm going to subtract this number, minus 1.17. That's the number we want. We don't want that big scary number. We got 1.17. So x equals 1.17. Other one, we're going to stay away from that big number. It deviates from the information we have now. So 1.17 is our answer for that one. Okay? What is the correlation coefficient? If you hadn't got it already, it's 0.91. That came in the information to the equation. 0.91 r squared equals 0.91. What information does the correlation coefficient have about this model? You can make very good predictions. It's very close to 1. And this data has a curve of best fit. Okay? So, last part we're going to do is review questions for the homework. It says identify each function that has a range of only real numbers greater than or equal to 1. Well, if I graph this curve, it is a curve that starts at 1, and its range is 1 to infinity. So greater than or equal to, that works. So A is 1. For the next one, 1/2 x plus 1 starts at 1. The range is...
Good morning again, West Potomac. Morning. Thank you very much. Have a great day, West Potomac.
So for C, the range, it goes from 1 up to positive infinity. C is an answer. And then for Y, the range is negative infinity to 1. So if you graph these, you'll be able to see it distinctly. So your answers are A and C. If you know transformations, you'll be able to see it as well. Saving a lot of work. E doesn't work because the range here, Y only equals 1. For here, the range starts at 3, goes to positive infinity, doesn't work. For G, the range starts at 1, goes to positive infinity, does work. And that was it. So those are my answers. Number 2, which graph shows that f shows f of x and the inverse of f of x? Well, if the inverse for x and inverse of f of x. So, if you recall from the previous units on inverses, this is unit 1, lesson 5, unit 1, lesson 5. If you intersect a graph at if you intersect two objects at more than one place, it's not an inverse. So basically,
Good morning, Miss Smith.
So sorry about that. So a good way you could look at this is just kind of figure out some numbers here. So let's say that right here, this is 1. Let's say this is 1. Let's say this is 1. Here's 1. Here's negative 1. And here's negative 1. So I'm just gonna kind of like show you how I would go about approaching this problem. And I'm just going to plot this in each graph. So this will help me kind of figure out what the inverse is. It's been useful to me. There's other tricks of the trade here, but this one's been the most effective for me when I'm trying to explain, not only explain, but also understand how inverses work. So the first thing I'm going to do, be heavy gauged. I'm going to just plot this point. It's like 1, 0. So my inverse, if I switch the two coordinates, should start at 0, 1, and it does. So this checks out. Over here, I have 1, 0. My inverse should start at 0, 1. It does not. It starts at negative 1, 0. This is not an inverse. These are not inverses. Over here, inverse starts at 1, 0, and it starts at 1, 0 here. But let's go ahead and graph this point. I have looks like negative 1, 0.5. That means if I switch those around, I should have coordinates at 5, negative 1. And I do not. The coordinates way over here. So this is not, these are not inverses. Next one, have coordinates at positive 1, 0. So my inverse should start here at 0, 1. It does not start down here. So this is not the inverse. The appropriate answer is letter A. Okay? And that wraps up that lesson. So I hope you guys have a good day. That was quadratic regressions with the additional review problem.